Namaste students, welcome to RH Chemistry Exam Navigator. So in Super 10 series, third series, second PUC Haloalkanes and haloarenes chapter I am going to discuss. In this case, question number 1, which of the following will react faster through SN1 mechanism? And note down this point, remember, very important concept in any competitive exams. You can see such questions on SN1 also and SN2 mechanism also. The option is given like this. So these are the options given. So once if you remember SN1 mechanism, which is a two-step mechanism in which carbocation is formed, right? So if the carbocation is more stable, the reaction will be faster. So hence remember, hint for this particular question is, as the stability of carbocation increases, reactivity increases. Hence now we will see in which case the carbocation stability is more. If you see that the second option will be the correct answer, we can see. The reason for that is, remember, this is the allylic halide. So allylic halide which is more stable due to the resonance, but remaining if you say carbocation is not that much stable. Because of that reason, second option is the correct one. Then question number 2. Of the following alcohols, the one that would react fastest with concentrated HCl and anhydrous ZnCl2. If you remember, concentrated HCl and anhydrous ZnCl2 is the Lucas reagent. The Lucas reagent reacts faster with tertiary then secondary then primary, right? The option is given like this. So very important, the hint for this particular question is, so react with tertiary more easily, which means faster, with the secondary then primary. Then we have to check out of the following which is tertiary. Hence I have given the structure. You can say 2-methyl propanol can be written like this. So this is primary one, right? So second, butane 1-ol if you write, this is the structure, this is also primary. And the third one, butane 2-ol, this is secondary alcohol, but 2-methyl propan 2-ol is tertiary alcohol. Hence we can say the answer for this question is fourth one. Tertiary alcohol react fastest is the hint for this question. Then question number 3. So in this case, which of the following compound will undergo racemization when the solution of KOH hydrolyzes? So always remember, racemization is the one, it is the process of conversion of D and L isomer, andre, so 2 enantiomer into the racemic mixture. The process is called as racemization, which means racemization is possible means there should be chiral center in the product. That is a very important point, remember, chiral center. So the option is given like this. So these are the 4 options which is mentioned. So racemization is possible only with the chiral center. So very simple, the hint for this question is optical active alkyl halide, andre, which has chiral carbon undergo racemization. So that you have to keep it in mind. Then you see in which case that chiral carbon is there. What is chiral carbon? Chiral carbon is nothing but the carbon which is surrounded by 4 different atoms or group of atoms. Then you see second option, third option and the fourth option, carbon is not surrounded by 4 different groups. But the option number 1, you can say the carbon of this CH attached to 4 different groups of atoms or atoms. So hence it is chiral. Hence the correct answer for this is first option. Then question number 4. In the following sequence of reaction, the end product C is. In such reaction, remember, so generally in the such question, they will combine 2 to 3 reactions in the one particular question. See here, CS3Br react with KCN to form A, on hydrolysis gives B, on lithium aluminum hydride gives C. So here what you have to remember is, alkyl halide react with KCN, what is the product formed? Then hydrolysis, what is the product? Then lithium aluminum hydride, that is a very good reducing agent. So reducing agent, which is the product. So given option is like this: ethyl alcohol, acetone, methane and acetaldehyde. So my dear students, what is the hint in this particular case? So that KCN, what is the KCN react with CS3Br? You are going to get cyanide. So remember, AgCN give rise to isocyanide, but KCN give rise to a cyanide. Very simple. So when cyanide undergo hydrolysis, remember hydrolysis, when cyanide undergo hydrolysis, you are going to get the compound NH3 plus COOH group is attached. So hence remember, so B is a CH3COOH, that is acetic acid is going to form. Nitrogen that is removed and CH3COOH is going to form. Hydrolysis agi. So then remember, you are going to get lithium aluminum hydride is given, right? Lithium aluminum hydride, this carboxylic acid, when it undergo reduction in presence of lithium aluminum hydride, you are going to get the product ethyl alcohol. Hence the answer for this question is 1. Question number 5. In this question, so this is the product given CS3, CS2, CHCl, CS3 obtained by the chlorination of N-butane will be. So they have given Meso form, racemic mixture, D form, L form. We know that D form and L form, this is the form of the optically active isomer. If that compound rotate plane of polarized light in the right direction, we write it as D form. If it is left direction, we will write it as L form. That we know. Racemic mixture also we know. Right? So in this case, racemic mixture means what? So racemic mixture is a mixture which is of equimolar proportion of the D and L isomer. But what is Meso form? Once I will tell you what is Meso form, then we will come back to this particular question. So Meso compounds, Meso form andre Meso compound. Meso compound means what? So Meso compound, remember, which will have a chiral carbon. See, it is not the other compound. This is also a chiral compound, but the thing is, the whole molecule is achiral due to plane of symmetry. Because of the plane of symmetry, remember, the whole molecule become achiral, but there will be chiral carbon. Very important point, remember about this. I will give you an example. So this is an example. You can see one carbon surrounded by, so OH group is there here, COOH is there here, H is there here, and this is the particular group is there here, which means the total compound is, remember, it is a chiral carbon containing compound. But there is a plane of symmetry. Plane of symmetry means if you cut that molecule into two half and fold that molecule, so OH on OH, H on H, and the COOH on COOH, you can see. This type of compound we call it as Meso compounds. Remember that, very important point. Now come back to this question. Obtained by chlorination of N-butane. See, Meso compound I have explained in detail means it is not the answer here. I will let me clear this particular point. That is not the answer. But what is the hint for this question? The hint for this question is mechanism of chlorination of N-butane. So which mechanism it undergo? Generally chlorination mechanism, if you see in the first PUC in class 11, so NCERT book, you have learned that. So chlorination of methane undergo free radical mechanism. So remember, chlorination of N-butane also undergo free radical mechanism. So hence chlorination of butane undergo free radical mechanism, that we come to know. Now free radical mechanism in which, if the free radical formed is tertiary, that is more stable than primary, secondary than primary. So when the free radical is formed, remember, so this is the compound, you can say, this is the one which will form intermediate as the free radical form. That free radical will be sp2 hybridized. Right? That sp2 hybridized planar free radical will get that just like a carbocation. So sp2 hybridized planar free radical. Hence remember, attack of that chlorine free radical take place from either side of the molecule. Either side of the molecule. It is just like, if you remember SN1 mechanism of optically active alkyl halide, you will end up with racemization. Similarly, here also remember, you are going to end up with racemic mixture. Hence the answer for this particular question is the second one, remember. So answer for this particular question is racemic mixture. Then question number 6. So this is the compound given. Alkene react with NBS, which is the product formed in the above reaction. The option is given like this. These are the 4 options given. So now you have to see now what is NBS. NBS, if you are not learnt, I will tell you what is NBS first, then we will come back to this particular question. Now see, NBS is nothing but N-bromosuccinamide. What is this NBS? N-bromosuccinamide. So N-bromosuccinamide, what is the structure? So this is the structure of N-bromosuccinamide. Then what is the role of N-bromosuccinamide here? I will give you one example. N-bromosuccinamide always converts, remember, alkenes to allyl bromides. Very important. Note down this point. NBS, wherever you will see, alkene get converted into allylic bromide. Allylic bromide. So one example I will show you. See, this is the one alkene, propene. When NBS react with this, the bromo substitution will take place not at this carbon. Remember, not at this carbon, it take place at this carbon. That is the importance of NBS. So you are going to get allylic bromide. So this NBS role, it is very clear now. Now we will see in the given particular compound, which one is the allylic carbon. See, this is one allylic carbon or this is one allylic carbon. Both are same. Right? Now you are going to get the compound when NBS which is used, then bromo substitution at allylic carbon. That is, this compound you are going to obtain. This compound you are going to get. So then what is the answer for this particular question? So answer is 1. So here very important concept. NBS, what is the meaning? What is the role you have to understand? Then go to question number 7. In case of the question number 7, you see, in the structure of the major product in the following reaction is, the structure of the major product in the following reaction. So this structure is given, NaCN and DMF is given, and the reactant, the options are given like this. So these are the 4 options mentioned. Clearly see that option, right? So next we will see NaCN we know. Then what is this DMF? DMF we will see once. So what is the meaning of this DMF? So DMF is nothing but dimethyl formamide. Remember, dimethyl formamide or DMF is a very good solvent in organic chemistry. In organic chemistry, it acts as a very good solvent. This is the structure of that dimethyl formamide. So always remember, dimethyl formamide, it is an polar aprotic solvent. Polar because nitrogen is having some lone pair and oxygen having lone pair. Okay, polar but aprotic solvent. It will not give you proton. Aprotic solvent. Always remember, out of SN1 and SN2 reaction, very important concept. Remember, out of SN1 and SN2 reaction, SN2 reaction will be faster if, remember, polar aprotic solvents like DMF is present. Because what it will do, it will does not decrease the nucleophilicity of the nucleophile. Very important point is, it will does not decrease the nucleophilicity of the nucleophile. Hence remember, it is a suitable solvent for SN2 mechanism. So now, in this particular case, you can see CN should replace. Remember, this CN should replace either this Cl or I. Now we know that this iodine attached to directly benzene ring means the double bond character will be present because of the resonance. Hence remember, this Cl is the best leaving group in this particular case. Hence remember, the product formed in this is CS2CN. CS2CN. So I will be as it is. Hence remember, the correct answer for this particular question is 4th option. Yes. Question number 8. In this case, CS3Br plus nucleophile, CS3 nucleophile plus Br minus reaction is given. The decreasing order of the rate of the above reaction with nucleophile A to D. They have mentioned the A to D nucleophile is like this. Clearly observe that what all the nucleophiles are present in this case. PHO minus, ACO minus, HO minus, CS3O minus. Now the option is set like this. Now you will see the option later. First you will see what is the hint for this particular question. When the such question is given, very important in this chapter, remember. So when such question is given, the hint for this is higher the basic nature. Remember, higher the basicity, greater is the nucleophilic tendency. So higher the basicity, greater is the nucleophilic tendency. Then which one is a stronger base in it? That you have to see. So which one is a stronger base in it? To see that, what we will do, we will see the conjugate acid of these. We will see conjugate acid of this, because as we know, a weak acid has the strongest conjugate base. So weak acid has the strongest conjugate base. Arranging the acid is very easy. Hence we write the conjugate acid of this, right? Then we get its base, the higher basicity. Now you will see, this is the acidic nature order. See, because ACOH is obtained from acetic acid, PHOH obtained from PHO minus obtained from phenol, HOH nothing but water, CH3OH is this methyl alcohol, CH3O minus obtained from CH3OH. Right? So, hence remember in this particular case, CH3OH, HOH out of 4 with the strongest acid is acetic acid. Acetic acid is strongest means remember weakest nucleophile is which one? CH3O minus, sorry ACO minus B. Remember, so hence I can write the nucleophilic tendency. See, this is the acidic order, correct? So nucleophilic tendency, what happens now? CH3O minus is more because this is a weak acid. Hence remember, so strongest base, then OH minus, then PHO minus, then ACO minus, which means CH3O minus is in D. D more than C more than A more than B. D more than C more than A more than B. So what is the answer? Option A, that is first option is the correct one. Then question number 9. Increasing rate of SN1 reaction in the following compound is. This is the second question I have taken in the series because very important question. So increasing rate of SN1 reaction series. These are the 4 options given. Very clearly observe these 4 options. Very important, remember. So aryl groups are given. Then the option is given like this. Once again, we will see the option later. First, we will see what is the hint for this particular question. Then what is the hint for this question? Once again, SN1 means two-step reaction. First step undergoes transition, that is the carbocation formation. The carbocation, if it is more stable, then we can say that will undergo the reaction very easily. So rate will be more. Now, carbocation is formed. So as the carbocation reaction SN1 directly proportional to stability of the carbocation formed. Right? Now methoxy group produces plus R effect. So here, now one after the other, if you see option A, you can see option A form carbocation after releasing this I minus ion, it will form a carbocation which is not stable. So in this case, carbocation formed will be, remember, like this. So I will show you, try to understand. So this is the carbocation which is not stable, right? Now for this carbocation, if Me, that is OCS3, methoxy group attached at the meta position, remember, meta position OCS3 act as minus I effect, very important, it will withdraws the electron. It will not donate the electron, it will withdraws the electron. But OCS3 will donate the electron where? When it is present in this para position. When OCS3 is present in the para position, it will act as a donating group. Now you can see, this is also donating group, this is also donating group. Out of these two, which one is good or produces higher plus R effect, if you say, that is methoxy group produces plus R effect to the greater tendency than CS3 group, methyl group. Because of that reason, remember, in this particular case, so the answer for this question, D is more. First option, D is more. Then if it comes to C, because out of CS3, OCS3, both are electron donating, but out of that, remember, OCS3 is more, hence D is more. Then remember C, then A, then last one is B. Last one is B, because here OMe, whatever it is there, this is minus I effect. It will withdraws the electron. Hence remember the option for this particular question, correct answer for this is, so remember, so answer 3. D more than C more than A more than B is the correct answer. Then we will see the last question in this series. Question number 10. The major product Y in the following reaction is. This is the reaction given. Very important type of question. Remember. So last April JEE question, it was last year 2019. Now you can see correctly which is the major product formed in this reaction. Now for this, first we will see what is the reaction. See, ETONA means which reagent it is. Very important in this chapter. Wherever you will see that ETONA, that is dehydrohalogenating agent. So the reaction take place is dehydrohalogenation. Remember, very important, dehydrohalogenation reaction. Wherever ETONA, CS3ONA you will get, that is dehydrohalogenation reaction. Sedgef's rule you have to remember. Now if you see, we will apply Sedgef rule to this particular compound, which is the product formed, that we will see first. So which is the product formed? See, you are going to get two product, because when this Cl is removed, you can get double bond at this position here, and double bond at this position, right? Then in this particular case, which one is major? That is very important. According to Sitjeff's rule, if you remember once, so according to Sitjeff's rule, that alkene is the major product in which lesser number of hydrogen attached to doubly bonded carbon atom. That alkene is a major product in which lesser number of hydrogen atom attached to doubly bonded carbon atom. So remember, this one is the one which is major in this case, and this one is the one which is minor according to Sitjeff's rule. Fine. We have got now what is X. X is major, this is the product. Now you will say what is Y. To know what is Y, you have to know the reagent given is HBr, right? HBr. Then what is this HBr? HBr, how it adds to this alkene? Remember one thing, that is Markovnikov's rule. Very, very important rule. Markovnikov's rule, right? Markovnikov's rule, what it will tell? According to Markovnikov's rule, the nucleophile attached to that particular carbon which is having lesser number of hydrogen attached, right? So out of these two carbon, remember, lesser number of hydrogen attached to this particular carbon. Hence remember, the answer for this particular question is this one. This is the compound which is the correct answer here. So now you select the correct answer. So the correct answer for this particular question is third option. So this completes 10 question in the Super 10 series. Next video I will come up with another chapter, that is from first PUC. Thank you for watching. So if you understood, like the video, share the video, and if you are not subscribed to my channel, you can subscribe to it. Thank you. Have a nice day.